Oh
Oh,
yeah.
there you are. I see you. I
Yes.
see you. Okay,
Yeah.
perfect. So Muzahir, I was just showing everybody our virtual reality
Oh yeah. I got him.
campus that we set up. So I don't know
Yeah.
how much of it you saw, but just
Yeah.
for we have a lot of people who joined early. So
Yeah.
anyways, do you want to? Okay, so everyone, I want to introduce you to Muzahir. Um, Muzahir Ali. He is doing some interesting work, as you all saw from the invitation. And today he's going to show us a little bit about what he's been working on and why it's important. And Muzahir, I introduce you to the AIU students who are joining us today.
Oh, thank you.
And we're very happy to be here together. And I've made
Yeah.
you I've made you
The,
co-host. So if you want,
okay.
whenever you're ready, you can begin either presenting or opening the floor as you wish.
Okay. Thank you very much for the invitation and providing me such opportunity. And yeah. So my screen is visible to you.
Yes.
Yeah.
Yeah. Okay.
Yeah.
Okay. Everything is okay.
Yes.
And
Perfect.
my voice is clear.
Yes.
Yes.
Okay. Good morning, everyone. Hope you are doing a great. And myself is Muzahir Ali, and I am a master's and doing master in mechanical engineering, and I am also a research assistant in nanomanufacturing technology lab at Chungang University, Seoul, South Korea. And today I am here to present my presentation on the hydrogen production by water electrolysis. So today presentation content contains introductions, applications, yeah.
Go ahead, Muzahir. No, I just muted because we have a lot of new students joining the Zoom.
Mm,
So since there
mm.
was a lot of noise, I just muted so that they wouldn't interrupt you. So
Oh, it's
please go
okay.
ahead. All right.
Okay. So, and the hydrogen production method and the water electrolysis and the catalyst used for the water electrolysis and how we can analyze and characterize these catalysts and conclusion. So as you know, the energy demand is increasing day by day, and the energy um, demand is increasing day by day, and the first to fulfill this energy demand, people are using more and more fossil fuels, and this because of the high demand of the fossil fuels, there is a rise in the price of the fossil fuels, and because of use of fossil fuels, there is also some environmental problems. So because of a lot of use of these fossil fuels, we have only a limited reserves of these fossil fuels. For example, we have only 150 years reserves of the coal, and and this is for very limited. And similarly, we have only 90 years of reserves of the uraniums, and a similar natural gas and oil, we have only 50 years of the reserves. So what will be, how we will fill our energy demands by after 50 years or after 90 years? So is there any solution or any alternative to this problem? So yes, we can do, we have a, yeah. So there's a one way to decrease our dependence on the fossil fuels by replacing them with the renewable and sustainable energy resources. So these resource Yeah, and these renewable energy resources include solar, wind, stars, and geothermal, bio, and hydrogen energy. So all these renewable energy sources are time dependent and the weather and depend on the weather conditions. So we could not depend only on the one reservoir. So we have to combine one or two or three together to fulfill our the energy demands. Out of these energy resources, hydrogen has been proved one of the cleanest and the most sustainable energy resource. And this, I think this can fulfill our energy demands. And as mentioned in my the title, the hydrogen production is just a process of creating a hydrogen gas. So where's the application of the hydrogen gas where we can apply the hydrogen gas? Hydrogen gas can be used for the it can be used in the fuel transportations and can be used in transportations like aeroplanes, car, buses, trucks, everywhere we can use in the transportation things. And this can also be used in the power generation, like we can produce electricity by using the hydrogen gas. And it is also used in industries like a refinery and others. And similarly, we can also use hydrogen gas to store energy, like a battery, for example. During the sunlight, we can produce a lot of hydrogen, and then we can store. So in this way, hydrogen can also be used as a storage. And similarly, it can be used in the aerospace and the jet engines, and hydrogen is also used to produce many chemicals like ammonia and methane, methanol, and yeah, and it is also can be used in the materials productions. So hydrogen how is the hydrogen demand is ongoing. For example, hydrogen demand only in the United States is projected to reach up to 773 million metric tons by 250. So the hydrogen demand is increasing day by day. It means that there are a lot of opportunities, and there will be a lot of jobs related to these sectors. So we can focus on these things. Similarly, and according to one research analysis, uh, at the end of 2030, uh, USA USA can 140 millions dollar can generate revenues. Similarly, this market in the European Unions could uh, could create a jobs of four like 50,000. So in this way, there is a lot of job opportunities, and there's a lot of things which are related to the hydrogen things. how how the hydrogen is used in the transportations and the refining sector. Nowadays, hydrogen fuel cell electric vehicles have many advantages over the simple electric vehicles. Like they have a very lower refilling times and greater mileage and smaller storage, there is a smaller need of the storage. And around about 3400 34,000 hydrogen fuel cell electric vehicles are running in the market in only in the North America. And some of the well-known companies like Shell, ITM, they are trying to build a 10,000 megawatt hydrogen electrocatalysis plant in the Germany. And similarly, BP they are combined. Uh, they have a plan to make a 250 megawatt electrolysis plant to produce hydrogen gas. And here's the model of the hydrogen fuel cell electric vehicles. Like it consists of the hydrogen cylinders, and there will be a one electrolyzer, fuel cell electrolyzers. So this uh, the hydrogen from these cylinders will just move to the fuel cells, and this fuel cell will convert the hydrogen gas into the electricity, and this electricity will use to run the motor, and this will be also stored in the battery. So in this way, the hydrogen fuel cell electric vehicles are working. And similarly, how about like 53% of the hydrogen is used to produce ammonia. So there is a big contribution of the hydrogen in the chemical sectors and the storage. For example, in general, this French multinational company uh, is also trying to integrate 100 megawatt electrocatalyst based hydrogen into its ammonia plant operations in Australia. So, and for the liquid hydrogen storage, improved insulated pressure vessels are being investigated. The US Department of Energy is also working on nanostructures being explored to extend possible novel hydrogen uptake mechanisms. And similarly, in the Japan, some companies are developing a hydrogen system which can be used to store the hydrogen for a longer time. And similarly, in the South Korea, uh, this university has also are trying to improve the hydrogen storage capacity. So after the hydrogen productions, there are some problem of the hydrogen storage. Some of the research is ongoing on the hydrogen storage, and some of the research is ongoing on the hydrogen productions. And there are different methods of the hydrogen productions, like steam.
Oh, excuse me, Muzahir.
Yeah.
Hi. I just wanted to give a chance for the students to see if
Hmm.
so far they had maybe any questions or comments. I
Okay.
don't know if so far what Muzahir has presented about hydrogen fuel as an option for a future generation of electricity. Did anybody have any comments or observations they'd like to share with Muzahir? Okay, I did have one. I was wondering,
Yeah.
Muzahir, you know, the drawback, one of the issues we've had with deploying hydrogen has been um, the use of electricity to generate the hydrogen and what is the net energy gain, because when you use electrolysis, you need energy to produce the hydrogen. And then number
Yeah.
two,
Hmm.
to transport the hydrogen like long distances also generates energy. So how have the technologies that you've seen addressed that issue so that it becomes a net energy gain, or where are we in that front?
Yeah, yeah, yeah. I am also coming toward your first question. Like, to produce a hydrogen, we have to provide electricity. So this is also reduce the production and efficiency of this method. I'm just coming toward that question. And the second question, to transport the hydrogen gas, there is a different way. Like, we people are working on the hydrogen pipelines and the hydrogen fuel tanks, and like the another gases, like another fuels, it can be transported. We can transport this. So yeah, then I will explain your first question in the next slide. Yeah. So there are different methods to produce a hydrogen gas, like steam methane or steam methane reforming, in which methane react with the steam to produce hydrogen and carbon dioxide. So this method has some disadvantages, like it's producing a carbon dioxide. And another method is electrolysis, which involves using an electric current to split water molecules in the hydrogen and oxygen gas. The another possible way is the biological process, which involves using microorganisms to produce hydrogen from organic matters. And the fourth one is the thermal decomposition, which involves the breaking down hydrocarbon into the hydrogen and carbon using heat. Out of these four hydrogen production methods, water, electrical, electrochemical water splitting, or water electrolysis has been widely recognized as a promising approach for efficient, green, and sustainable hydrogen production. So I am just coming to your first question. So what is the water electrolysis? Actually, in the water electrolysis, we provide electric current to the cell, and the cell consists of the two electrodes. One is the known as the anode, and another is known as the cathode, and they are separated by some membrane. And anode is connected to positive terminal, and then cathode is connected to negative terminals. We and At the anode there's some oxidation reactions happens, and because of this, the at the anode oxygen gas is produced, and the cathode there's a reduction reactions happens. So because of the reduction of the water, hydrogen has produced at the cathode. So uh yeah, as you said, it is the drawback of the water electrolysis to supply the electricity. So there can be a one way to fix this issue, like we can get this power by using our renewable energy sources like solar or wind energy. If we get some energy from solar and wind, and connect and use that electricity to run the water electrolysis, uh, which is known as a green hydrogen, and it is the more cheaper as compared to other water electrolysis process. So what happens at the at the cathode, water molecules just take the electrons and reduce into the hydrogen and the hydroxyls ions, and at the anode, water is converted into the oxygen and the hydrogen and electrons. So this water electrolysis totally depend on the medium of the electrolyte medium, electrolyte medium, like if the electrolyte medium is is a alkaline medium or acid medium. So and on the basis of media use, we can say we can divide it into alkaline electrolysis and acid electrolysis. So alkaline electrolysis is also known as the aqueous electrolysis, which use an alkaline solution such as the potassium hydroxide as the electrolyte, and the acid, also known as the high temperature electrolysis, and use an acidic solution such as sulfuric acid as the electrolyte. So both the methods have some advantages and disadvantages. Some of the uh, advantage of the acid electrolyte medium is that it require a less energy to produce a hydrogen gas, but it faces some problem like uh, it cause a Korean problem, and the our electrodes are not stable in the acid medium. So this is the drawback of the acid electrolysis, and alkaline electrolysis also has some advantages over the acid electrolysis. This alkaline electrolysis is more stable, and more stable, but and there is no problem of the Korean, and we can use at the high temperatures. But the main problem of the alkaline electrolysis is that it require a more electricity. It means that its efficiency of the alkaline water electrolysis is not a good as like the acid electrolysis. So because of the uh, stability issues and the industries, and the most of the industries are using alkaline water electrolysis because it is more stable, and the hydrogen produced by this method is pure, and it can be used at the high temperatures, and it's environmental friendly. So the whole water electrolysis depend on the electrode material which we are using as a anode or a cathode. So before moving toward, I would like to explain the what kind of the materials are being used in the water electrolysis at anode and a cathode. So we can divide electrode materials into three groups, like noble metals and the non-noble metals and the non-metals. So noble metals, which include a platinum group, they are very highly efficient, and their efficiency is very high in the alkaline medium, and they are showing excellent uh, catalytic properties. But uh, there is some drawback of using these electrode, is that high cost, and the use of these electrodes make the whole process uh, very expensive. And the and, another problem is that they are very rare and limited supplies. So these materials cannot be used in the real-time applications. So um, then the no research is going on the non-noble metals, which include the iron, cobalt, nickel, copper. So this group shows a good catalytic property toward the HER, but they are not as good as like the noble metals, and they are the order toward the hydrogen production is as shown in the nickel has the very good catalytic properties toward the HER. And but there's this group also faces some problems, like there is problem of the Korean if we are using the non-noble metals like iron, cobalt, or nickel and copper. They are not they are not as stable, and they are not stable. So during a water electrolysis, they combine together, and um, it cannot be used in the strong acidic or alkaline media, which are the necessary for the good efficiency of the water electrolysis. And so because of these problems, no other research has gone toward the non-metals, which include the boron, copper, nitrogen, carbon, nitrogen, phosphorus, sulfur. So because of the stability issues, the people are more focusing on the non-metals, and but these non-metals generally do not show the good catalytic property toward HERs. But there are some exceptions, like if we dope the nitrogen, oxygen, or sulfur, or if we into the carbon, or if we create a porous structure of the carbon, then it shows a good performance toward the HER. But all alone, they are not showing a good properties. And another advantage of using the non-metal is that we can change their morphology and surface chemistry easily, and both of these factors play a key role in the exposing and stabilizing of the active sites for the efficient catalysis. So although non-metals are not a good alone, but a lot of research is ongoing because they are more stable as compared to the non-noble metals. And the people are mixing many mm, non-metals into the carbon, and doping a different non-metals and metals, and to make the noble metals, people are also using some carbon shells to cover the non-noble metals, so that the stability can be increased. The only problem of the is the stability problems, like in the very strong acidic and alkaline medium. their stability is not good. So my work is also on the non-metals. I am also working on the carbon, porous carbon, nitrogen doped porous carbons, and and I am also using the alkaline medium. So these are the materials which are being used as electrode in the water electrolysis for the hydrogen productions. And how we there's a question is that how we can check their performance towards hydrogen productions, evolution reactions. So there are different techniques to check the uh, performance of the catalyst toward the HER, like to check the surface chemistry or surface morphology. Mostly people are using a scanning electron microscope. Uh, and here is the image of the scanning electron microscope. We can see the interior structure which we cannot see by the naked eye. So we can see either this structure is a porous or not a porous, and what kind of the structure it is. And to determine the elemental compositions, like what kind of the material is inside our final product, mostly people use EDS, EDX, EDX, and XTS methods are used to check the elemental compositions, like what kind of the materials inside the electrodes are, and to check the surface chemistry, like in the surface, what kind of the materials are existing. So people are also use XPS, and here is the XPS result of the one material. So by using XPS analysis, we can see what kind of the material inside are in. So as you can see, as this is the XPS analysis of the porous carbon electrode, and there is a highest amount highest amount of the carbon, and there is a nitrogen, oxygen, there is some amount of the sulfur and silicon. So by using XPS analysis, we can check the surface chemistry, as the hydrogen production and the reaction or hydrogen evolution reaction is also a surface analysis. So we can check the surface morphology or surface chemistry by using XPS. And there's another technique to check the nanoparticle size, grain size, and size distribution and morphology of the our electrode, is the transmission electron microscopy. All these techniques use the electron beams to check the surface morphology, composition, and other things. So by using these techniques, we can easily check our electrode properties. And so the next question is that how we can check the this our material or our electrode is a good for the is good for the hydrogen production or not. So there are many analyses to check these things. Mostly people are using uh, linear sweep voltammetry analysis. In this analysis, we provide a potential to the our electrode, and there are some reference electrode and some the counter electrode, and we measure the current, and by measuring the current we can analyze how good our electrode is. And uh, the there's another analysis to check the uh, which is the to check the mechanism of the water electrolysis or the hydrogen production analysis, is the Tefel slope analysis. I think there is some mistake in this slide. Yeah. By using a Tefel slope analysis, we can check how fast our reaction is being happen, and what is the rate determining step of our reactions. So, and to check the our um, um, electrical and chemical electrical properties, like conductivity and resistivity of the electrode. Mostly we use the electrochemical impedance spectroscopy. And the to check the stability, which is the most important for the electrode. For the hydrogen production, mostly people use chronopotentiometry or the chronoamperometry. So by using these techniques, we can check the electrochemical performance of our electrode toward the hydrogen productions. And uh, this is mostly used method to check the electrochemical performance. And so this was the, yeah. And so the conclusion of the today presentation is, water electrolysis is the best method for producing a hydrogen gas by using an electric current. And it can be most efficient if we use electric current from produced from the renewable energy sources, like if we get electric current from the solar or the wind energy or hydro energy. So this hydrogen production by water electrolysis can be a most efficient, and by using this technique we can fulfill our energy demands. And it is the second thing, it is very clean and environmental friendly process. By the uh, during the combustion of the hydrogen, the byproducts are the oxygen and the water molecules. So oxygen is also good for the environment, and water is this method has a no uh, bad effect on the environment. And the water electrolysis is also being already used in the commercial market to produce hydrogen. However, the cost and efficiency of process are still challenge. There are some challenges, and the research is ongoing to develop more efficient and cost-effective method of the water electrolysis, and as well as advanced technologies for hydrogen storage, distributions, and use. The work is still in the progress, so there is a lot of work is ongoing. So this was the end of the presentation. Thank you very much.
Thank you, Muzahir. That's
Yeah.
excellent. I have a few questions here that were posted on the chat while you were
Yeah.
presenting.
Yeah.
Maybe some you already covered in your slides, but I'll go through them.
Mm.
I see here from Lakma Persad Rama. Um, I don't know if you want to ask your question, Rama. What is,
Uh,
or do you want me
um,
to ask it for you?
Now I've put the question, and my question was, what is the lifetime of a hydrogen generating cell?
Lifetime, it's depend materials to materials, like different materials have different lifetimes. And a lot of research is ongoing. The big problem of the hydrogen cell is the stability problem, like a lifetime problem. Most of the materials are not showing a good performance, and they are not stable, and their lifetime is short. So the most of the research is still ongoing for the non-noble, for the to check the lifetime. But mostly the non-metals, most of the electrodes composed of the non-metals are showing a good life performance and good stability.
Okay, thank you very much.
Yeah.
Perfect. I have someone here raise their hand. Adetona Adetunji. Oops, sorry. Go ahead. I just unmute. Sorry, I accidentally hit the wrong button, and I think I muted you. Sorry. Go
Oh,
ahead.
thank you, Dr. Rick. Thank you.
My pleasure.
Musa, that was a very good presentation. That was excellent.
Thank
I
you.
just want us to consider the economical perspective of your work, because you know the global village is going crazy now. There's a lot of competition when it comes
Yeah.
to new innovation and techniques.
Oh yeah.
So how effective is it going to go? How far is it going to go when you look at the economical perspective, the cost implications compared to all other alternatives we have? Thank you.
uh there's there's some problems, and there are some advantages and some disadvantages of this method, and this is just a initial stage, and a lot of work is people are focusing on these things. This is just a beginning. So and we did not have another option beside this energy, like a heterogen energy. We did not have any uh, alternative solution to fulfill our energy demands. There are some problem, but uh, yeah, mostly people are focusing on these things, and hopefully this will be the future next fuel of the world. Hydrogen fuel will be the next fuel, hopefully. Yeah.
Thank you, Muzahir. And there's a couple of questions about, what machine is used to produce hydrogen. I think for your selected method, electrolysis, just to
Mhm.
kind of simplify, we're basically talking about a filter that when you apply electricity, it causes the oxygen and hydrogen atoms to
Mm.
separate.
Yeah.
So when someone asks what type of machine is used, uh, how would you
Oh.
simplify that?
Um, Actually, we in the laboratory we are using a potential state, and by using a potential state, we apply the current, and there is actually we are using a cell. Uh, Actually, in the lab scale, we are not producing too much hydrogen and oxygen. We are just analyzing the performance, and we are just prototype use the sample as a prototypes. So actually, in the cells, there's a mostly a membrane which separate the oxygen and the hydrogen. Yeah.
Yeah, I mean, basically, it's such
Mm.
a simple process, but
Yeah.
the materials and the efficiency is the part of the equation that you
Yeah.
are still working on to figure out so that it's a
Yeah.
net positive. Okay, let me see what other questions we have here posted in the chat. Oh, well, yeah, here's, I guess, the most important question. Um,
Yeah.
can this process go for mass production? And when do you anticipate, with, I guess, with the pace of the advance of the technology,
Hmm.
that you think it will be ready for mass production? If maybe there's already places where they are producing it
Oh,
at scale.
yeah. Yes, this method is the most suitable method for the mass production, and a lot of research is going on the water electrolysis, and it can be a most efficient method for the mass production. So it can be, yeah.
Okay, excellent.
Mm.
Let me see what other question. If you have a question, if you want, you can raise your hand. Um, in the, there's like an option that you can, um, you can request, you can kind of raise your hand. If not, feel free to ask a question to Muzahir about, I see here one. It says, I work in the plastic industry. This is from
Mm.
Simon Kimani. Do you want to
Mm.
ask your question, Simon? Simon Kimani, are you still here with us? I think yes, that was only 8 minutes ago that Simon asked the question.
Yeah, what is the question?
Okay, the question is, I work in the plastic industry.
Hmm.
How best can this process be efficiently used? I guess maybe to power the
Oh,
processes in the
uh,
plastic industry.
yeah, yeah. This can be used to power the plastic industry, and the yeah, yes, to power we can use, and there can be another perspective. If it's depend on the materials we can use in the production of some materials, if there's a use of the hydrogen and that plastic or those things. Yeah.
Okay, and Muzahir, we'll see if somebody else has any other questions. In my case, I wanted to ask.
Hello.
Yes, go ahead, Omar.
Um, yes, I want to
Omar.
ask Muzahir, to what extent do you think this can help solve the energy demand in Africa?
In Africa, like this is a totally to produce a hydrogen. We need a water, and by using a water electrolysis, uh, without the water we cannot produce hydrogen. If we have a water, we can produce a hydrogen, and this is a most efficient way until now, which has been proved by research, and it can be used for the mass productions. So nowadays the research is ongoing to convert the seawater into the hydrogen gas, but there are some problems to convert the seawaters into the hydrogen gas. But some people are successful converting the seawater into the hydrogen. Yeah.
Okay,
Fantastic.
Yeah.
thank you.
Yeah,
I also wanted to welcome Dr. Freddy Frejus. He joined us for today's meeting as well. He's a member of AIU. I'm sure maybe some of the students have had a chance to work with Dr. Freddy. Hi, Dr. Freddy, how are you?
Hello, Dr. Ricardo. I'm doing fantastic. And thank you very much to everyone. And Happy New Year to everyone. And we're
That's
going
right.
to have an excellent session. Thank you.
Thank you, Freddie. Welcome. Thank you for being with us. Muzahir, how would you see the competition of, I think this question was already asked, how do you, how will this compete with other energy sources? Because, I mean, for example, we have nuclear, which obviously has some dangers, but, as far as taking a certain amount of matter and converting it into almost limitless energy, there's very few things that can compete with
no.
nuclear. So I was wondering your thoughts on nuclear, and then on another follow-up would be, uh, you know, battery storage from renewable lithium ion and other technologies like that, even biofuels, which take like feedstock that is typically thrown away or burnt to convert to energy. It seems like all of these energy sources, with all the research going into it and all the scientists working on it, it looks like everybody is lowering the costs,
uh,
of these methods. So the question is, I mean, is this kind of like a race that hydrogen production can beat, or do you think that the advances in lithium-ion batteries, the advances in solid-state batteries, the advances in biofuels and nuclear, in other words, like at what point will hydrogen be able to scale or to lower the cost faster than what the other sources are already lowering their costs by? I guess that's the question.
yeah. So starting with the nuclear things, like nuclear also depend on the uranium things, and the uranium is also, according to World Nuclear Associations, we have limited resources of the nuclear, like a uranium, although there is a lot of work is ongoing yet. And the second thing is that many things are uh, going together, like batteries and the heterogens. People are doing many things. So each research, each work has a different applications. I have a like a it's depend on the demands. Like for example, uh, by using a heterogen can be used as a power generations, and it can also be used to store the electricity in the, like in the, if, for example, if we take the case of the solar system, it's depend totally on the weather and the time. So for we can take energy for a special time, although there is a lot of work is ongoing on the solar panels. So these are the time dependent and weather dependent. But by using nitrogen, we can produce electricity every time, anytime, whenever we,
Fantastic.
yeah, whenever we want.
Yes.
So
Yeah, it's really amazing,
yeah,
all of these possibilities. I mean, I
yeah.
think just a few years ago, I don't know if anybody here in today's session has heard about the nodules that are found deep under the ocean.
Mm,
There's these nodules that apparently have all of the elements to make batteries.
Oh,
And
yeah.
you know, they're at the bottom of the ocean, and so there's a couple of companies that are developing technologies to kind of vacuum up these nodules. And so, you know how you mentioned where uranium, the Nuclear Association says we have 90-year supply. I guess similar to lithium and carbide and other materials.
Yeah.
All of a sudden, we've discovered a new source that kind of increases our supply by, you know, by 5 times more. So it's really amazing how quickly kind of things can change.
Yeah, but it will take us some times. So in case of the batteries, they are also depending on some materials, and it's depends on the availability of the materials. And for example, if the materials go for the material shortage, there will be similar case like a fossil fuels, as they are going to short it, they are decreasing in depletion because of depletion. So yeah, there's some every energy sector has some advantages and some disadvantages, and it's depend on the application, what for which purpose we are going to use.
Thank you, Muzahir. And Sunil Hari Prasad is asking, Sunil, do you want to ask your question, or should I ask it for you?
Basically, seems that we are going in this direction, hydrogen fuel for the industry, in terms of the quarrying industry, excavators and loaders, because we know we do contribute a lot to pollution in terms of exhaust emission. How is hydrogen going to impact on us in terms of providing sustainable power? If you sometimes change from fuel, you don't get it power. How is it going to affect us in that case, and how soon we could look forward to something like that?
Oh yes, your question is very good, and I appreciate. So the environmental pollution is another problem of this world, like a carbon dioxide and greenhouse gases. So in case of the hydrogen energy, it is totally pollution free, because during the burning of the hydrogen, the byproducts are the water and the oxygen. So the oxygen is good for the environment, and the water is also good for environment. So this is a totally environmental friendly, and which yeah, there will no such kind of problems. Yeah, and it can be more favorable to our environmental and sustainability. Yeah.
Fantastic. Do we have any other questions for Muzahir, or in general about energy, hydrogen? Just so you know, I'm looking at the schedule. We have tomorrow a presenter who is going to share with us a little bit about biomass
Oh.
conversion to energy. So it'll be interesting. You know, everyone who's
Yeah.
here today, if they want to listen to that, I think it's a great kind of continuation from the conversation. Muzahir, do you have any comments relating the biofuel conversion? I know there's some controversy in the past where we were using you know, actual food to convert to energy, which of
Yeah.
course, you know, we don't want to do that because it drives the cost of food up, and there's scarcity
Yeah.
of food, and there's hunger in the world. But there's also biomass that's kind of like waste, you know, like
Yeah.
could be even. So what do
Yeah.
you think?
It's depend on the process, like uh it is good for environment or not. So it's what kind of process they are using, it's depend on it. Yeah, it may be good, it may be not good for environment. Yeah.
Perfect. Please, Dr. Al Hakimu Diallo, please join us. Ask your question, please.
Yes, Muzahir, I want to know what is
Yeah.
the equivalence between the consumption, electricity consumption to produce 1 kilogram of hydrogen, or one meter cube hydrogen, the
Yeah.
equivalence between.
Yeah, it's depend on the different environment and in case of the water electrolysis, it's depend on the medium and materials. And for example, in the case of the if somebody is using a platinum electrode for the water electrolysis, it is very efficient. I don't really have any exact figure, but it is very efficient if somebody is using a platinum. But it's the price will be very high because the platinum is very expensive. So
Right.
overall the price will go well high, and the yeah, because of the high price it will be not efficient, although we will have a big amount of the hydrogen, but it overall its efficiency will be low. Yeah, it's depend on the materials and other things, so I cannot figure out. uh yeah.
What about after we've converted it to hydrogen? Like once you already have the storage of
Yeah.
hydrogen, you've already completed the process. What about the energy density of hydrogen? Can the hydrogen can the hydrogen be compressed
Oh yeah, I had
in
yes, yeah.
size? Okay,
Yeah,
so
yeah.
what would be the energy density, for example, of a compressed hydrogen versus an uncompressed hydrogen? Comparing it to, just so we have an idea of, okay, if we wanted to power, a city or a building, how
Mhm.
much area for storage would we need for the hydrogen?
The density of the hydrogen is very low, and
Okay,
so uh, to further transportation and to further yeah, for transportation people are using compressing the hydrogen so it can be transported, because it is has a very low density. And
okay.
yes, and some of the people are trying to convert hydrogen gas to liquid, so it can be transported easily.
Okay.
So yeah.
So let me ask you this, to get down to like where we are at, like the optimal efficiency. If you were to take the energy that we
Mm,
have from hydrogen, we have the hydrogen ready. This is the
mm,
amount of energy it has. Out of
yeah.
that energy,
Mm.
would you say that 80% of that energy was used to produce the hydrogen, and maybe 10% to compress the hydrogen, and maybe 5% to transport the
Trans
hydrogen? Like how would you break down the net value left over
uh,
from all of those
uh,
steps right now?
although in case of these steps, the efficiency of the hydrogen is less as compared to the batteries. Because of this problem, it is having a less efficiency as compared to batteries. So a lot of work is going on it. If people are trying to create a hydrogen hydrogen station, hydrogen producing station, and a supply station together, so the transportation cost can be minimized. And there's a lot of factors which are being under research and people are trying to minimize, but it has some advantages over the rechargeable batteries. But the overall efficiency is a little bit low as compared to rechargeable batteries because of these factors like transportation, compressing, yeah, which make it a little bit expensive.
Excellent. And so let's say that right now we're kind of let's say that we're negative 5%. Like in other words, like the hydrogen
Uh,
provides 10
uh-huh,
kilowatts power,
uh,
but it
mm,
costs us 10.1 energy to generate that 1 kilowatt. So we're negative by 10% or 5%. At
yeah.
what at what point would it become scalable? Would it be at the point where it's a net positive of 50% or a net positive of 20%? When do you think that will make it scalable, I guess? And how far away are we from that? Are we a couple of years, 5 years? What's
Uh,
your projection?
Many industries are and the companies are working on it, and so it's a it's a totally depend on the electrode materials and the environment also. like uh it is this process is also depend on the temperatures things temperature regions, and so depending on the environment, and its efficiency can vary at the different region. And different medium, different materials, its efficiency can be vary. So
Okay.
we cannot say uh, until we have a specific conditions, like specific things, then we can decide.
Okay. I have one last question. I think we're running towards the end of the hour that we have allotted. Evelyn Giassi. Evelyn, would you like to ask your question, or would you like me to read it? So Evelyn Giassi, she asks, how about a small scale production, like for example, in a residential buildings that have solar panels, places that
Yeah.
are secluded, that are far away from an electric station. Can that source be produced in small scale for residential buildings that
Oh
have
yeah.
solar panels? Yeah.
Yes, and it can. There is a different name of the hydrogen. So by using a solar panel, like a solar energy connected with the hydrogen things, it is a green hydrogen, and it is the most efficient way to produce a hydrogen. And a lot of work is ongoing in this process, and it can produce at the you can produce at the small scale, on the large scale, by using this process. Yeah.
Okay. If somebody wanted to implement that with the whatever the most affordable, I mean, it's still experimental. In other words, it wouldn't be feasible right now to connect solar panels to a hydrogen generation, or would it be economically feasible? Right now, it's still kind of in the lab, right? Where it's not ready yet, or is it?
Uh, it's in the North America. This is a system is already installed, and there are more than 1,000 vehicles which are running on the hydrogen fuels. And
Right.
yeah, so we cannot say this is just still limited to the laboratory. It is also
Okay.
being used practical and real time. So yeah.
Fantastic. And what about for like the small scale, like Evelyn was asking? In other words,
Yeah.
if what would it cost for, like, let's say it's like a small building that has maybe 20 residents in it, relatively small building. What would be the cost of, not the solar panels, because we already know solar panels are a separate system, but what would be the investment that that community of maybe 20 residents would have to make to use that solar energy to produce the hydrogen for storing the energy? I mean, is that something that would cost $100,000, or would it cost $20,000? Where are we approximately in the affordability?
Uh, as I already mentioned, these things, like it's a depend on the environment. Like for example, as I told, it's water electrolysis. It's totally depend on the water availability, if on the water. So we should also consider the water amount and the water price, and as well as, and uh, we have to use some the fuel cells and electrolyzers. So around, I cannot figure it out. It's like a, it depends material to materials, and depends environment to environment. So
Correct.
I cannot figure out. And this, maybe this will be in some area, it will be for $20,000, and another area maybe $10,000.
Yes.
So
Yeah,
yeah.
that's the idea. Like, just to have an understanding of what we're talking about as figures. I understand it could vary a lot, but just to have
Yeah.
a grasp, if it's something that would be 10 to 20,000, I think that's
Yeah.
getting close to being, adaptable in some places. So
Yeah.
we're not too far away. And then
Yeah.
one more question, Muzahir. When we're using, what type of water can be used? In other words, does it have to be purified water, or could it be waste water, or could it be salt water to do the electrolysis?
Yeah, this is a good question. So and the uh the efficiency of the this process also depend on the water. Like if the water, normal water or journal water is also can be used for the water electrolysis to produce hydrogens, and the salty water can also be used. And but there will be a difference of the efficiency. Every water can be used, but there will be the efficiency will be different for each water.
Okay.
Yeah, yeah,
Okay. Okay, excellent.
yeah,
Well, this reaches the end of our presentation today. Muzahir, you've been with us already
yeah.
for 1 hour, and we've enjoyed your presentation. There was a lot of great
Yeah.
questions. I
Thank
think
you.
I think I got all of them.
Yeah.
So yeah, these are tough questions because this is such a broad area
Oh yeah,
of study that
yeah,
I think, you know, the project that you're doing with some of the
yeah,
questions from today, I think we have 2 or 3 more research projects to.
yeah, yeah.
Uh, so I think our students are welcome to tackle all those areas and try to
Yeah.
find us more and more answers. But I really thank you, Muzahir, for being a guest here today and for
Okay.
presenting us your research.
Okay. Thank you very much for inviting me, and thank you.
My pleasure. Thank you so much.
Thank you, everyone.
So if you want to stick around for a couple of minutes, I will share my screen. For those who weren't here earlier, students, I wanted to show you a feature that few have found. It's here in the student section. So when you log into your student section, here I am in my student section. And let me see, my video is glitching a little bit. Okay, so if you can see in your student section, we have 2 places to enter the virtual reality campus. One is here, the other one is student resources. And you enter the virtual reality campus, and it's really interesting. You can, if you have a 3D headset, you can put on your 3D headset and kind of look around this virtual reality environment. Before we enter the lobby, I wanted to show you guys, we've added this kind of interesting hover feature.
I checked you so far.
So
You get this thing here, but I don't think that is what it is, because
BA18
Oh, that's interesting.
Moto?
so it's kind of a first attempt, you know, to get something something that's a 3D environment.
And I
So
the oh, that's not 3J. Same one.
so we're back here to the lobby. We enter the lobby, and I know some of you saw it already at the beginning, but there's a lot of students who joined us afterwards. So I just wanted to take a moment to show them the lobby. You can go to an auditorium. So today's meeting could be played in the auditorium. And we also have some break rooms. If we go to the AIU, we can go to the online library through here. We can walk to the hallway. And in the hallway, you have access to different phases. The phase 1 of your program, phase 2 of your program. So here, all of our students are familiar with this introductory video for the phase 1. So it's kind of a new, different way to, you know, to interact virtually. So I just, I hope you all have a chance, an opportunity to try it out, and including all the other tools and features we have there. We have a lot of tools and features, and we hope you guys can all take advantage of it and enjoy your journey at AIU. So thank you everyone so much for joining us today. We have another presentation today at 3 o'clock Eastern Standard Time US, that's New York time. The 3 o'clock presentation is going to be on health and wellness. So you're welcome to join us. It is in Spanish. So if you want to practice your Spanish, you're welcome. However, we do have the next English session will be tomorrow at 9 a.m. As I mentioned, it's related to today's topic. Instead of hydrogen electrolysis to make energy, it is converting biomass to energy. So if you are interested in today's session, I think tomorrow you will also find it very interesting. Freddie, is there anything else you wanted to comment? If not, I just wanted to say, wish everyone a good afternoon and a great day, and hope to see you again soon.
No question. No question for now.
Thank you so much, everyone. Thank you for joining us.
Thank you,
Have a blessed day.
Okay.
Take care.
Thank you very much.
Ciao, ciao.
Thank you very much. Thank you very much.
Bye. A pleasure.
Thank you very much. Thank you very much. Thank you very much.
A pleasure. Fantastic. Good to see
Thank you very
everyone.
much. Thank you very much.
Thank you very much.
Dunil, thank you very much for your participation.